Hello everyone and welcome. In today's explainer, we're going to break down the building blocks of the internet, that's network devices and protocols, in a really simple way.
Have you ever wondered how that email or message you send manages to get to the other side of the world? It's actually a lot like a city's postal service. You need two key things. You need the post offices, which is our network hardware, and you need the rules for addressing the letters, which are our network protocols.
Okay, so let's continue with our postal service analogy. First up, let's meet those post offices, the actual physical devices that lay the foundation for this entire communication network.
So, first on our list is the modem. The easiest way to think about it is as your computer's personal translator. You see, your computer speaks in a digital language, while internet lines use analog signals. The modem translates your computer's digital signals into analog to send them out, and then converts the incoming analog signals back into digital so your computer can understand them.
Next, we have the Network Interface Card, or NIC. Now, if the modem is the gateway to the outside world, the NIC is like your computer's local address. Think of it like your specific house number on a street, which ensures that data on the network gets delivered right to your computer.
If your Wi-Fi signal is ever weak, a repeater takes that faint signal, boosts it back to full strength, and then sends it out again, almost like it's brand new.
A hub is kind of like someone shouting in a crowded room. Everyone hears the message, even if it was only meant for one person. As you can guess, it's not very efficient.
Now, an upgrade from the hub is the switch, which is a lot smarter. Instead of shouting, a switch is like whispering a secret directly into one person's ear in that same crowded room. Data only goes to the specific device it was sent to, which makes the whole network faster and much more efficient.
This slide is really important from an exam point of view, so pay close attention. Where a hub just broadcasts data to all connected devices, a blind broadcast really, a switch actually checks the data packet and forwards it only to the specific device it's intended for. That's why a hub is considered less sophisticated and a switch is considered more so. Your Wi-Fi device at home? That's a router. It works like a traffic cop, directing the data coming from the internet to the correct device in your home, whether that's your phone, your laptop, or your TV.
And finally, we have the firewall. This is basically the security guard for your network. Its job is to monitor all the incoming and outgoing data traffic based on a set of security rules to make sure no unauthorized access can happen.
So, we've looked at the hardware, our post offices, but how does the work get done inside them? For that, we need rules and a common language. In the world of the internet, we call these rules protocols.
You can think of protocols as the grammar of the internet. They make sure that every device can correctly understand what the other devices are saying. Now, what's really interesting about this slide is the S in HTTPS. For exams, always remember, S stands for secure. It's the difference between sending a postcard for anyone to read versus sending a sealed, private letter. Whenever you click the Send button on an email, SMTP, or Simple Mail Transfer Protocol, is doing all the hard work behind the scenes. It's the protocol responsible for carrying your email from your mail server to the receiver's mail server. Basically, it's the email's postman.
All right, let's see how much you've learned. Here are a few quick questions, exactly like the kind you might see in your exams. Take a moment to think it over. We'll look at the answer on the next slide.
The right answer is POP3. Remember, SMTP sends mail, but to receive mail, we use protocols like POP3 and IMAP. POP3 specifically downloads the mail from the server onto your device.
Remember, we talked about the internet's phone book? What was its name? Exactly. DNS, or Domain Name System, is the phone book of the internet. We humans remember names like Google.com, but computers only understand numbers or IP addresses. DNS is what translates those names into numbers.
Think about it. Whenever you connect to a new Wi-Fi network, how does your phone or laptop get a new IP address?
The correct answer is DHCP. That's Dynamic Host Configuration Protocol. Imagine if you had to manually set up an IP address every time you went to a new coffee shop. DHCP does that work automatically and makes our lives a lot easier.
Great job on the quiz. Now that we've seen all the individual components, let's put everything together to see the big picture and summarize the key takeaways from this explainer. So, the bottom line is this. Network devices, like routers and switches, are our physical infrastructure. They're the roads. And network protocols, like HTTP and DNS, are the rules of communication. They're the traffic laws.
Just like you can't have cars on roads without traffic laws, you can't have hardware that works without protocols. Both are absolutely essential to make the internet run.
This is a huge question to think about. With billions of new Internet of Things devices coming online, how will we manage that massive amount of traffic and ensure security for everyone? It's definitely something to consider. If you found this video helpful, please don't forget to like, share, and subscribe to the channel. For all the PDFs, join my Telegram channel. The link is in the description.